Welcome back. Piecewise Functions. In grade 11, when you were doing functions, and even as you kind of started advanced functions, you pretty much just deal with one function at a time, and then you create your domain, or you find your domains, and then you find your ranges, and then that's about it. But very often what happens is that our function might be made up of pieces, which are not just coming from one particular, let's say, parent function, okay? So they're broken down. You might be given a particular domain, and under that domain, so for that restricted input, it might be mapped onto a particular function. And then for a different input, it might use a different function. So here I just want to present a few examples to show you, okay, what these piecewise functions are. They're not very difficult. They can be both. They can create a continuous or discontinuous function, and I'll show you that. But the key thing is that they're made of pieces. So there's more than one piece when you're going to be kind of plotting it out and seeing it on a graph. So here is my first example. So I have an input x, which is standard. I have my function f of x, and then I have my output. Now my function is actually going to be restricted to these two pieces, meaning if my input is less or equal to 0, then I'm going to take on, at least my function is going to take on negative 2x, which really is just a line, right, with a negative slope. Now, if my input so happens to be greater, let's say, than 0, then my function takes on a different piece or a different function, and in this case it would have been negative 3x squared, which is a parabola, which is kind of reflected in the x and then stretched out a bit. And here what you will see is kind of a function which is made up of two pieces. So if I plot this, now I can sketch this out. I mean, we're good enough now in terms of these sketches, especially when the functions are coming from some parent functions that we know. And in this case, that's definitely the case. So here is my x. And so the first one, which is going to be, so if I kind of go back in here, so for x, which is less than or equal to 0, okay, it's going to take on negative 2x. So if I drew this, again, I'm just going to kind of sketch this out. So here is my 0. Now I know that this is going to kind of go off, okay, and it's going to continue on with a slope of negative 2. So it's kind of going off in this direction. If I'm coming in here, it's coming down. If I'm going up in the negative, it's going there. So that's my piece number 1. Okay, so I can say, okay, I'm going to just label this, okay, so piece number 1, and that's coming from here. Now, piece number 2, okay, is going to be here, and that happens when my inputs are greater than 0. Now, one thing you will have to be careful with your functions when you define them, if you're given them, most of the time, that will happen. Just please make sure that you're not defining, okay, your input for two different pieces at the same point. So for instance, I don't want to do something like this. I don't want to say that this is for x, which is greater or equal to, because now I run a problem of having my input, okay, notice being in both of the pieces. So they have to be disjointed in a way, okay? So I'm going to remove this. Now, negative 3x squared, again, I kind of know how this looks like. I'm going to draw it in a different color just so that it stands out. Now, it's not at 0, okay, but it's everything kind of beyond 0, which is going to look like kind of something like that. And it blows up on us, maybe even faster. Now, notice that in this particular case, so this would have been your second piece right there, and the function is made of two pieces, and that's why we call this a piecewise function. Now, it's still continuous. There's still continuity in this particular function. But these piecewise functions don't have to be continuous. Now, continuous, remember, means that there's no break, okay, at all in between. You can just continue on, okay, and there's continuity, okay, in your function. So if I, for instance, so if I remove this, and let's say that instead of having negative 2x, I would have put in here plus 2. that would have shifted our function. So this particular function, it would have moved it up, okay, somewhere up to here. Let's say if that was 2. And in here, I'm going to remove, I'm going to kind of go in here and try to remove this, kind of this right. That's not what I wanted to do. Okay, let me make this smaller. Okay, so I want to remove this piece. Okay, and in here, now what's going to happen is, so this is my, my 2. And now the other function, okay, because it's starting at 0, okay, so in here, I'm going to put a little circle. And that's, if you remember, that's how we would actually plot these things. Okay, so it's not defined for 0, my second piece, but it is defined for everything which is greater than 0. So now, again, this is still made of 2 pieces that I have, but now this function is discontinuous. There is a break. And that can happen in piecewise functions. So in piecewise functions, you can have something like this occurring. Now, it can be even more complicated. There can be many more pieces than just 2. It can be 3, 4, 5, or how many you like. They also don't have to span the entire domain, meaning defined to be for all x. They can be defined within a particular domain, which is not necessarily going off to negative infinity or positive infinity. So you can cap them. Okay, and the function can be defined only for a particular domain, which might be fixed and does not include all x. So that can happen. Now, other things that can happen is that you might have, so instead of, for instance, just being pieces where it's actually pieces lines that you notice, okay, so there's some continuity in these pieces, it might so happen that you might even have something like this. Let's say if I now remove, if I go back to my first piece and I'm going to say, okay, here, let me remove this. I'm going to remove that. And that removal means that now, okay, and what I'm going to try to do, because I have, the beauty of doing this digitally, so I'm going to shift this down a bit. Okay, so let me do that. I'm going to remove this. Let me redraw it. So in this case now what I would have is, because I removed, and for my first piece what I didn't have, now I don't have this at 2. It's supposed to be now a circle, okay, because it doesn't include 2. Okay, so it can be something like that. So now it's designated, okay, so that these pieces, they're actually not defined at x is equal to 0. So that can happen. So the pieces can be defined for certain regions, but they may not be defined for other regions. In fact, I could have made this not to be 0. I could have said that let this be less than -1. And in that case, what would have happened is, so in here, I would have to shift this kind of over and remove. So let me partially remove in here. So you might have something like this, where it's only, say, came up to here, and let's say that was -1, and then all of that, okay, was gone. So we would have had something like this, all right? And this right here, let's assume that that was -1. So notice there would have been a gap. So your pieces would have been defined for different domains, okay? Other items that can happen, so if I kind of go back in here, let me redraw this, hopefully it still remembers. What might happen is, okay, I'm going to shift this down now a little bit, and I'm going to define, if I bring this down, I could do something like this. I can say, okay, well, in here, so this was for, let's say, 0 right there. And then I would say for x equals to 0, I could map this to, let's say, and this was equal to just 1. So when that happens right here, this would have been my third piece. Since I have 1 and 2 on the other ones, I'll put this as 3. But what would happen is that means, oh, okay, let's say if this was 1, okay, so that means that now it's made up of 3 pieces, and one of those pieces is just a point. And that's what actually piecewise functions are. So you can now create many different types of functions which look really funky, okay? Because now you can kind of piecewise them together to create a much more complicated function that you have. All right. Now, how would you actually graph this? Let's say if you wanted to put this into Desmos, you can do it. The only thing is you're going to have to remember that within Desmos, okay, you're going to have to put these restrictions. So I'm going to actually plot this one just so that you can see it on Desmos how to do it. All right. So let me just load up Desmos. All right, so here is Desmos that you see, and then on the left-hand side, we see our piecewise function. So what I'm going to do is I'm going to say, okay, so minus 2x, okay, plus 2. And then, so if you remember, now restrictions, we want this to be restricted to this, okay? So that's going to be our first. And then there's nothing happening, okay, at 0 there. Now my second piece, okay, would have been that I'm going to actually plot the point. So I would have here plotted the point. In this case, it's 0, 1, because it's only one particular point. So notice it plots it there. So that's my second kind of piece. And then I can put that I want to plot negative 3x. This was squared, but I want to restrict this to be for x greater than 0. All right, and now you have this nice plot within. Let me move this over so that we can see it. Okay, and I'm gonna shift this out of here so that we can actually see this. Okay, so obviously mine is not as nice as this one, but hopefully now you get the gauge and kind of understanding how you can plot these piecewise functions. All right, so when you can do that way. And we can complicate these as much as we like. So here, if I give you maybe a final example, and I'll just kind of make it up from, you know, numerous other functions, and then we'll plot it on Desmos, just so that you can see the pieces, okay, being put in together. So imagine that we're going to have a new function. Now, one thing that I do want you to know is that typically when it's written out in textbooks, or sometimes your teachers cover it, they like to write, okay, so this function right here, if it's piecewise, they're not going to really structure it like this for you, but what they will do is they'll do the following. So I'm going to make up, let's say, a new one. So let's say g of x, all right? And now g of x, okay, is going to be made up of pieces put in together, all right? So g of x is going to be equal to, and it's going to span out, okay, several. So you might typically see it written like this. Let's say that I want this particular function, okay, to be, so let's say negative 2, let's say x cubed plus, let's say 5, and then comma, and this would have been defined for, let's say x, which is, so typically we go from left to right. So let's say this was going to be x, which is less than, okay, or equal to negative 3. That would have been my first piece. My second piece, okay, is going to be, so let's put this in, and I'll put, this is going to be x, say plus 1. This is the absolute value function, and this is going to be for basically x between negative 3. Now, it was already defined there for negative 3, so x is going to be greater than negative 3, but let's say less than, and I'll put here 2. All right, so that would have been my second piece. Now my third piece, I'm going to say, so this now goes beyond 2. Okay, so let's put this one as negative, and let's say put x, you know, plus 1. Let's make it to the 4. Okay, plus 1. So making it complicated here, and this would have been for x, which is going to be greater or equal to 2. And now notice, so I have now defined it. Okay, so here, those will be my domains, and then my g is going to take on 3 pieces, depending on what the input is. So typically, you'll see it written out like this, where they'll give you the function, and then they'll tell you what the domains they're defined for. And now, of course, we can sketch this out. We kind of know these because it's a cubic function, it's an absolute function, and then a quadratic, so it's a power function. So we kind of have an idea what the parent functions look like, so we can sketch it out if necessary. But I also want to show you how to utilize decimals to try to plot these, okay? And this is going to be a piecewise function made up of 3 pieces. And here it is. So let me bring back decimals. So I'll bring it back, okay? And let's stretch it out. So that was my first one. I'm going to hide these away, and then we're going to now plot my g of x, which is going to be 3 pieces. All right, so in decimals, let's plot this out now that we've kind of hid the other ones away. So first one is -2 x cubed. This will be +5, okay? And then we're going to put the restriction. So this is going to be less than -3, less than or equal to. So that's going to be our first kind of piece that we have there. Now our second one, it's supposed to be an absolute value. So x, let's say +1, okay, absolute value, but it is between, so sorry, I can't put a comma there because then decimals doesn't like that. So we have to put it in brackets. So -3 less, okay, and then this will be 2, all right? So now notice this will be my second piece. Okay, so that's what I have in there. So notice it got shifted. Okay, so notice there's a huge discontinuity there in between. Now let me put the last piece in there, and that's going to be -x + 1 to the 4, and finally +1. And this is for x, which is greater or equal to 2, and that would be my last piece. All right, so then there's going to be another discontinuity there as well. So I'm going to just, let me get rid of this so that we can see the whole function, okay, all the pieces in. So there we have it. Now, don't think that that second piece is a flat line. It is actually absolute values, because if I zoom in here, then you'll notice that that's exactly what it is. Right? It just so happens that the other functions I made up, okay, are just so much further apart. So we have 2 discontinuities there, one at -3 and then one at 2. So there's clear breaks there. And this piecewise function is made up of 3 pieces. All right, so I hope that this gives you a concept and idea what these piecewise functions actually are. You can, of course, ask numerous other questions with regards to piecewise functions, and you can create some pretty neat, cool applications. But the goal of this video was to try to show you and introduce you to piecewise functions so that you don't feel like it is something beyond you. Okay? So thanks for watching. See you in a future video. Cheers.